Hello, I'm Ray, the Ray in the Ray code. In this video, I'll be covering the adapter design pattern, and I'll be using C++, not C#, but C++. Although I do other tutorials in C# and other programming languages, this video will be in C++. But don't let me prevent you from watching those videos. In fact, I encourage you to check them out, but don't leave this one. That seems to be another metric that YouTube looks at. You can do this. Tell your friends, put it on your cover letter, resume, and say it in your voicemail. Share it on your social media, and I'll share it on mine. I understand this is the optimal way to go viral. I have put timestamps in the margin so you may navigate to the section you desire most. My favorite is SWOT analysis. I use other programming languages to cover this design pattern. I have used this programming language and other design patterns that are put up by the Game 4. Please like this video, leave a comment, and subscribe. The Ray Code can be found on all social media platforms. Please search them out and become a Ray Code groupie. What is the adapter design pattern? The adapter pattern acts as a bridge between two incompatible interfaces. In essence, it allows for two different classes with incompatible interfaces to work together by converting the interface of one class into the interface the other class expects. The adapter pattern can be seen as a wrapper that modifies the existing class interface without altering the underlying code. The adapter pattern typically involves three roles. Target. This is the interface the client expects or uses. Adaptee. This is the existing interface that needs to be adapted. Adapter. This is a class that joins functionalities of independent or incompatible interfaces, i.e. it makes the adaptee interface compatible with the target interface. Importance for C++ developers. Reusability of legacy code. C++ projects often involve legacy code or third-party libraries. Instead of rewriting these components, the adapter pattern lets developers make this old code work with new systems. Increased compatibility. Developers might work with libraries or modules that have different interfaces. The adapter pattern helps make them compatible with the rest of the application. Increased compatibility over time software requirements change. An existing interface might become insufficient, and instead of refactoring the old interface, an adapter might be used to bridge the new requirement with the existing interface. Isolation of code changes. When dealing with large code bases, changes can have unforeseen side effects. Using adapter pattern can help isolate the areas that change, minimizing potential impacts. Clear separation of concerns. The pattern encourages developers to keep conversions of adapter logic separate from the actual business logic. This clear separation promotes clear and more maintainable code. Principle of least knowledge. Adhering to principle where a given section of software should know as little as necessary about the other sections. The adapter pattern ensures that the main parts of the application remain decoupled from the specifics of adapted interfaces. Enhanced development process. During the development process, teams can work in parallel. One team might develop modules with one interface, while another team might expect a different interface. The adapter pattern can bridge these differences, allowing for parallel development without waiting for one team to adjust to the other specifications. In summary, understanding the adapter design pattern equips C++ developers with a tool to bridge incompatibilities between different interfaces, fostering reusability, scalability, and maintainability. It's especially valuable when integrating legacy code, third-party libraries, or collaborating in large teams environments where different modules might have varying interfaces. Structural pattern adapter for C++ students. Target defines the interface the client expects to use, represents the standard way objects should behave, used directly by the client. Client works with objects through the target interface, does not know about the adaptee's interface, uses the adapter to interact with the adaptee. Adapt-T has an existing interface that is compatible with target, contains useful behavior the client needs, cannot be changed easily. Adapter implements target interface, translates client's request into Adapt-T calls, connects incompatible interfaces safely. Hello, I'm Ray, the Ray in the Ray code. In this video, I plan to give you an example of the adapter design pattern, which is a structural design pattern. We start with a class we call target. The target class provides an interface in which the request method clients can utilize. Here, request simply returns a default message. We start with the class structure. Here, request simply returns a default message. At the top, I need to include the IO stream. Let's create another class we call Adapt-T. The Adapt-T is one that has a different interface, specific requests that clients may expect based on the target class. We include target at the top. This is a class you might need to adapt in order to make it work seamlessly with existing or new code. Here, specific request returns a string in reverse order. The intended message seems to be the Ray code is awesome, but it's written backwards. Now we create the Adapt-T. The Adapt-T class is one that has different interface specific requests that the client might expect based on the target class. This is a class you might need to adapt in order to make it work seamlessly with existing code or new code. At the top, we include algorithm header and a reference to the Adapt-T. We extend the adapter with the target interface. We set a private variable Adapt-T. Next, we have the adapter take an Adapt-T. And we reverse the string that was given by specific request, so translating the message. Now let's go to main for our demo. At the top, we include algorithm and the adapter we created. We add some client code. We set up the target. We set up the Adapt-T, and we pass the Adapt-T into the client code that we just created. Let's do some cleanup and run. We get client. I can work just fine with the target. Adapt-T, the backward message. Client, but I can work with it via the adapter. In the adapter, translated, the Ray code is awesome. Remember to code with a smile. SWOT analysis of the adapter design pattern for C++ programmers. S. Strengths. Compatibility makes interfaces work together, enabling seamless integration with legacy systems in C++. Code reuse leverages existing implementations without modifying the internal structure. Extensibility decouples client code from specific implementations, allowing future changes without breaking incompatibility. W. Weakness. Performance overhead may introduce slight runtime overhead due to added indirection layers. Complexity adds additional abstraction, which may complicate small or simple systems. Temporary usefulness often becomes redundant once legacy code is refactored or deprecated. O. Opportunity. Legacy integration commonly used in C++ projects to modernize integration with legacy libraries. API mapping maps third-party libraries, creating a unified interface for clients. Cross-language bridges connects C++ code with systems written in other languages like Python or Java. T. Threats. Bypass risk. Clients accessing underlying incompatible interface can compromise the adapter's integrity. Over-engineering. Excessive reliance on adapters might clutter the design. Simpler alternatives. Refactor or direct integration may achieve the same goals with less overhead. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment and find me on all my social media platforms. But most of all, Tell a friend the Ray code is awesome.